I'm Phuc, CEO and co-founder of Phuc Labs, and our connection with MIT is Rick Fontana, who is an undergraduate and PhD here in 85. And we're here to talk about machine vision-based particle sorting. As you know, modern life depends on industrial processes to separate particles from water. Sometimes we wish to clean water to return it to natural ecosystems. Other times we're focused on extracting valuable materials suspended in the water. Scarce resources underpinning the modern economy necessitate that we recover and reuse these precious materials, both in solids and in liquid. And to achieve separation, even the most advanced techniques today are still analog and have not changed much in decades. Membranes, gravity filters, aeration consume large amounts of energy and require labor-intensive maintenance. For example, drinking and waste treatment systems require more than 4% of the energy used globally. And the search for more innovative water solutions is becoming a critical global priority. At Phuc Labs, we use robotics to automate the process of identifying, separating, and reclaiming particles from water. We use the latest innovations from machine vision to identify particles in a stream of water, much like different types of packages moving along a conveyor belt in a warehouse. Then we use hardware to slice the water and divert it to various destinations, one for water and others for different types of particles. We can quickly identify particles using imaging sensors, spectral response, or other sensing technologies. And our sorting system can be easily added to existing operations and typically uses 1/3 of the energy of filter-based systems because we're not constantly forcing water through membranes. With the ability to continuously and cost-effectively identify and separate particles from a stream, we can not only replace and enhance many filtering applications, but we can also do things that filters cannot. And this opens entirely new applications and markets. We're focused on battery recycling as our initial beachhead because there's a compelling business case that we can uniquely solve. Currently, battery recyclers process the black mass, the cathode and anode materials, and what's left over are aluminum and copper metal components, which are blended and sold as low-grade copper. Our technology can differentiate between the silver and the aluminum and the brown and the copper and uniquely sort these metals. And by doing so, we create a new aluminum revenue stream and increase the yield for more concentrated copper. And altogether, we can improve the top line revenue by 50%. As mentioned, for battery recycling, there's a compelling business case that we can uniquely solve for. And in addition to working with North America's largest battery recycler, we want to work with more battery recyclers to see if we can become the standard for metal sorting. And we're also working with mining projects in South Africa and the Philippines, and want to work with more companies, particularly for alluvial and platinum group metals mining. And we believe that we can create an automated low energy system for metal extraction. In the case of industrial wastewater, our system can recover valuable metals within high-end manufacturing processes and enable particle sorting in the same way that Amazon created and redesigned the warehouse automation market. Our technology can be applied to any industry that transports particles within fluids, such sectors as recycling, mining, agriculture, food and beverage processing, and many others. And our solution potentially provides an essential toolkit for fluid-based logistics and automation and provides yet another toolkit for humanity to tackle climate change, energy, healthcare, and other critical challenges. My name is Phuc. You can contact me in the breakout room or phuc@phuclabs.com, phuc@phuclabs.com, P-H-U-C. Thank you.
That was great. So talking about battery recycling, how did you choose that as your initial market, even though there's so many other applications you've touched on?
Great. So basically, we wanted to focus on things where we have high extraction value, A, B, that our technology was a great fit for. So in this case, by the time the battery gets to us, right, the materials get to us, the black mass has already been gone. All these other materials have been removed, and all we have left is water, copper, and aluminum. And previously, before we came along, the only other option was smelting or other types of high energy, ecologically unfriendly material types of processes. And so, and also finally, the future proof, meaning that there's a lot of EVs that one day we will be recycled. For example, the number of cars today will be recycled in 10 years. We can project that pretty easily.
Got it. Thank you. And how would you say you're different from other AI-based technologies?
I would say we were the first to actually realize that you can do this in a microfluidic way, and that you can do it in water. So I would say, again, compare us to a conveyor belt, but in this case, the water is actually the conveyor system, and the interaction and the piston action between seeing it and cutting it, that's actually the innovation that we've come up with.